Today, we're going to discuss VizLint, an automated tool for detecting bugs in web UI design. Currently, vision language model is very best at detecting bugs in web UI. So what is the reason behind this? Firstly, web UI are very complex with many interconnected components like the button, the form, and dynamic element, making bug detection very challenging. Another issue is the white space. In the UI, lab blank errors are often tokenized by the vision language model, but since they contain no useful information, they add more complexity by increasing the number of meaningless tokens. Additionally, the abundant visual element creates noise that can distract the model, making it harder to identify some issue. Here is a screenshot of a web UI showing a bug. Specifically, this is an example of an issue with sorting order. As you can see, the layout is not displaying correctly. In the example, when the model processes the original screenshot without any guidance, it produces an incorrect detection result. However, when we ask the visual queue as a bounding box for all UI component, the model attention is directed more speeds correctly. It leads to the correct detection of bug, and you can see here, this clearly demonstrates the importance of providing structural visual annotation to improve bug detection accuracy. Before doing some demonstration, let's look at our methods overview a little bit. First step is UI description. Our system analyzes the screenshot and instantly creates the structural text description that highlights the key element and overall layout. Next is hypothesis generation. We use the description in the previous step. Our highlight predict potential bug by spotting out some inconsistency. And then we come to the localization step. We use Omniparser to add some bounding box around component in the screenshot and get and overlay the attention heat map over it. We annotate some bounding box with high attention score. It means the model focus more on the area to verify to see the corresponding hypothesis. And lastly, we verify X hypothesis using the annotated image with bounding box from previous step. And then we create the detailed report and return it to the user. We also tested two naive baseline. First is direct prompting on the original UI screenshot. And second, I'll highlight with our visual queue in step 3 and verification using only original image. Our method outperform both because it breaks the bug detection into clear fine-grained step, mimicking the human thinking, and add some visual cue to focus attention, improving accuracy and reducing distraction. Now come to demonstration part. Firstly, we start with uploading a screenshot image of the UI web. In the first step, I use GPT-4o to generate the UI description of a given screenshot image. After that, we use UI description and the image to generate some hypothesis about the inconsistency. One inconsistency contains the correct behavior as expected, some possible bug, and some component to check to have to look annotate in the original image. And in the third step, I try to localize some component and draw some bounding box using the omniparser and attention heat map to overlay to see which area which bounding box has high attention score and keep the bounding box on the annotation image. After getting some annotation image with bounding box as a visual cue, I use it to verify the X hypothesis. I will walk through all the hypotheses that's generated in step 3, in step 2 to verify it. And you can see this is the process of verifying X hypothesis. And I also display the verification result to see, and you can train it as you want. And after generating all the verification results, we can click to the generate bug report. It will accumulate all the results from the hypothesis and write the concise bug report. You can see the bug report here is contains the title, and you can check it correctly detect the bug in the example that I state in the motivation about the sorting function. It also localize the buggy error in the screenshot. So this is the end of my demonstration. Thank you a lot for listening.